In the last video, we learned how to find the zeros of a function. Let's do two more examples and start with the function f of x equals x minus 3 over x minus 2. We see that the zero of this function is 3, because the graph intersects the x-axis at 3. Let's find the zero of this function algebraically. Recall that when the graph intersects the x-axis, the y-coordinate at their intersection is 0. So we can write 0 equals x minus 3 over x minus 2. Now we have to isolate the x. But before we do that, we have to get rid of the denominator. How can we get rid of the denominator? Feel free to pause the video and think about it. Recall that we can get rid of the denominator by multiplying the equation by the denominator. On the left-hand side of the equation, we have 0 times x minus 2, which is going to be 0. And on the right-hand side of the equation, we are going to cancel out x minus 2. So we get 0 equals x minus 3. And after adding 3 to both sides of the equation, we get x equals 3. So the zero of this function is 3, and we are done with finding the zero algebraically. Let's look at the next function, f of x equals the square root of 4 minus x squared. We see that the graph of this function does not intersect the x-axis. I chose this example because I wanted to show you that it's not necessary that the graph intersects the x-axis to get zeros of the function. It's enough when we have a point on the x-axis, like here in this example, to get zeros of a function. So we see the zeros of this function are negative 2 and 2. Let's find the zeros of this function algebraically. Again, we just have to plug in 0 for f of x. So we can write 0 equals the square root of 4 minus x squared. After squaring each side, we get 0 equals 4 minus x squared. And after adding x squared to each side, we get x squared equals 4. Now we have to take the square root from both sides to get rid of the square. Recall, when doing that, we get a positive and a negative square root. So 1 0 of the function is the square root of 4, which is 2. And the second 0 of the function is the negative square root of 4, which is negative 2. And we are done with finding the zeros of this function algebraically. We saw in this example that to find the zeros of a function, the graph of the function does not necessarily have to intersect the x-axis. It's enough when the graph, let's say, touches the x-axis. If you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.